Good morning, students. Today I am going to discussing about what is that Devission and Germer experiment. Okay, so here, according to de Broglie hypothesis, the particle such as the electrons, protons, neutrons should possess wave like a nature. So last class we are already discussing about this one. Okay, in this experiment, these particles. So in this experiment, these particles having the wave nature should undergo the diffraction. Okay, so it means these particles means what is that? Neutron, protons and electrons having wave nature should undergo the diffraction. Okay, here the two American scientists Devission and Germer were the first in 1924 to demonstrate the diffraction of the electrons in 1924. Okay, so the two American scientists, they are Devission and Germer, were the first in 1924 to demonstrate the diffraction of the electrons. Okay, here in this experiment we have to prove that what is that Devission and Germer prove that the fast moving particles, that is the electrons, protons or neutrons, anything, okay, but that will be shows the diffraction. Okay, so this is the we have to prove this one in this experiment. We have to prove that what is that the fast moving particles shows the diffraction. Okay, here the next one, what is that? This is the experimental picture. So in this experimental in this diagram, what is that? This is the high HT means what is that? This is the high tension potential battery, high tension battery. So this is the low tension battery, and this is F is what is that? Filament, that is the electron gun. Okay, so A is what is that? That is the cylinder. Okay, that is the cylinder, and this is the nickel target. So this is the nickel target, and this is the electron beam. Okay, and this one is what is that? Diffracted electron beam. This one, a diffracted electron beam, and this is the what is that? Scale. Okay, so this is the scale, and this one what is that? Movable collector. Movable collector, and this movable collector connected to the sensitive galvanometer. Okay, and this one what is that? Vacuum chamber. So this one what is that? Vacuum chamber. So here, so this is the construction of the experiment. So here what is that? First one what is that? Electron gun. So this is the electron gun. Okay, this is the F. So here in this experiment, it consists of a tungsten filament. So this is the tungsten filament F. Okay, that produce the electrons. That will be produce the electrons by process of the thermonic emissions. So this electron gun, that will be produce the electron emission. That will be emit the electrons. Okay. The next one, high tension battery. So here we have to connect it to the low tension battery, and this one is we have to connect to the high tension battery. So high tension battery we have, that will be provides the suitable potential difference to accelerate the electrons. Okay, so here what is that? The filament will be emit the electrons, and this electrons will be accelerated by the high tension battery. Okay, the next one we have to use what is that? Cylinder. So this is the cylinder. A is the cylinder. So in this cylinder, it will provide us a fine beam. Okay, that will be provides the fine beam of electrons. Okay, it means that these electrons will be incident on this. That will be passing in this cylinder. That will be fine beam of electrons will be passing this cylinder. Okay. So next one, what is that? Nickel crystal. So this is a nickel target or nickel target. So the nickel crystal, it acts as a scatter. It means the incident of the electron beam will be, that will be scattered. Okay, here that will be scattered and perpendicular to the plane of the paper. Perpendicular plane of the paper. Okay. So next one, electron collector. This is the movable collector or electron collector. This is the movable collector or electron collector. It means it will be capable of rotating about this same axis as the nickel crystal target. So this means that will be capable of rotating the about the what is that? Nickel target. So nickel target is electron beam bರ್ತೈತಲ್ಲ ಆ ಒಂದು electron beam that will be rotating. Okay, ಅಲ್ಲಿ ಏನಾಗ್ತಿತ್ತಪ್ಪ that will be rotate ಹಾಕೊಂತ ಹೋಗ್ತೈತಿ. Okay, the next one, galvanometer. We have to this movable connector that will be connected to the galvanometer, and this galvanometer what is that? That is connected to the electron collector, and this deflection is in the galvanometer is proportional to the intensity of the electron. It means we are getting the current in this galvanometer, that is the intensity of the electron beam. Okay, so that is the intensity of the electron beam. Okay, the last one, what is that? Vacuum. This is the vacuum chamber. Okay, it is enclosed with the entire apparatus. This is enclosed with the entire apparatus. So this is the construction of this experiment. Okay, so this is what is that? Construction of this experiment. So next one, the next working of this experiment, working of the Devission and Germer experiment. Here, apparatus used by the Devission and Germer consists of electron gun. So this is the electron gun, which has a tungsten filament, F heated by the low voltage battery. Okay, so this is a tungsten, this is the electron gun, and this electron gun will be made by what is that? Filament. What is that? Tungsten filamented, and this tungsten filamented, that will be heated by the low tension battery. Okay, so we have to applying the low tension battery, we have to apply low battery, low on the voltage, we have to apply this. Okay, the next one, that the electrons will be emitted. So here emitted by the filament. Okay, here the what is that? Electrons will be emitted, but that will be accelerated through the non-potential difference applied by the high voltage battery, but it will be emit the electron, but it will be accelerated by the high potential battery. Okay, so we have to apply the high potential battery. When we have to apply the high voltage, that will be accelerate, the electron beam will be accelerated. Okay, ಯಾವಾಗ ಇದು low battery tension battery ಹೋದಾಗ that will be emit the electron, but when we have to applying the high potential battery, when we have to applying the high voltage, that will be accelerate the electrons. ಏನಾಗ್ತೈತಪ್ಪ ಅಂದರೆ that will be accelerate ಆಗ್ತೈತಿ, that will be high accelerate, that will be high voltage battery ಕೊಟ್ಟಾಗ that will be accelerated. Okay, so next one, a fine beam of electrons is obtained. So here in this cylinder, we are getting the fine beam of electron is obtained by passing the electron through the cylinder. So here when the electrons will be emitted, that will be passing through this cylinder, that will be fine beam of electrons will be passing through this cylinder, that will be incident on the nickel target. Okay, then the beam taking nickel target is normally, that will be incident on this nickel target normally. Okay, here the electrons are diffracted. Okay, when the electron beam is incident on the nickel target, that will be diffracted. Okay, in the different direction. That when the listen here, when the electron beam is incident on the nickel target, that will be diffracted in the different direction by the atoms of the nickel crystals. Okay, so next one, the intensity of the diffracted electrons is measured by along the entire into a movable collector. Here, so when the incident on this nickel the electron will be incident on this nickel target, that will be diffracted. So that will be diffracted electron beam. So this diffracted electron beam will be what is that? Electron will be measured, or it will be measured the intensity, that will be measured the collector, movable collector, that will be collecting. Okay, so here that will be connected to the galvanometer, and when diffracted beam electron beam will be getting the movable collector, that we are getting the current. Okay, listen here, when the electron beam will be incident on this nickel target, that will be diffracted. Okay, so it is diffracted, what is that? The intensity of the diffracted electron is measured by the allowing it to enter into a movable collector, and which is connected to the galvanometer. Okay, here movable collector can be rotating along the circular scale, that will be rotating along this is the circular scale, and that will be rotating. Okay, that it will be rotating along the circular scale. Okay, so this is the working of the experiment. What is that? Just listen here, this is the filament. Okay, and this filament will be heated by the low tension battery. Okay, when this we have to applying the low battery, low voltage, that will be filament will be emit the electrons. Okay, but this electron is accelerated by the high potential battery. Okay, when we applying the high potential battery, that will be the electrons will be accelerated, and that will be passing to the cylinder. That will be fine beam of electrons will be passing, this fine beam of electrons is passing to the nickel target. That will be incident on the nickel target, so that will be diffracted. Okay, the electron will be, when the incident on the nickel target will be incident on the nickel target, that will be diffracted. Okay, that will be diffracted, and that will be, we have to connect the movable connector, that will be incident on the movable connector, and we are getting the small current, that will be, we are getting the current, that will be intensity of the electron beam. Okay, that the current is, what is that, intensity of the electron beam. So this is the experiment. So here we have to apply, what is that, we have to start with the experiment. The accelerating potential is kept at a 40 voltage. Here we have to apply the low voltage, we have to apply the only 0 to 10, that will we have to apply the 5 voltage low tension. Okay, when we are applying the 5 voltage, that will be, filament will be heated. Okay, and that will be heated, and that will be emit the electrons. Okay, and that will be emit the electrons, and now we have to applying the 40 volt. Okay, this one we have to applying the 40 volt, applying the high tension battery. When we have to applying the high tension battery, that will be the electron beam will be accelerated, and that will be passing the cylinder. Okay, when that will be passing through the cylinder, that will be fine beam of electron will be incident on the nickel target. Okay, when the electron beam will incident on the nickel target, that will be diffracted, and finally we are the collector will be movable collector will be, that will be collect the diffracted electron, and we are getting the galvanometer in the current, that will be intensity of the electron beam. Okay, so this is the working of this experiment. Okay, the next one. Okay, so here we have to applying the 40 voltage. Okay, again that will be, we have to applying the 44 voltage. We have to applying the experiment is repeated for different potential, that will we have to applying the different voltage, that is the 40, 44, 48, 54, 64, 60 and 64 voltage, and we are getting the smooth curve is obtained. Okay, when we are applying the 40 voltage, we are getting this one. When we are applying the 44 voltage, we are getting this one. When we are applying the 48 voltage, we are getting this one. When we are applying the 54 voltage, we are getting this one. When we are applying the 60 voltage, we are getting this one. When we are applying the 64 voltage, we are getting this one. When we are applying the 68 voltage, we are getting this one. Okay, this we are getting the smooth curve is obtained. Okay, here as the accelerating potential is increased, for example, that will be 40 to 64 voltage, that will be increased gradually, the little bump begins to appear on the curve. So here we have to getting the 44 voltage, we are 44 voltage, we are getting the little bump. So this is the bump, we are getting the bump. Okay, the 48 we are getting the more bump, 54 we are getting the more bump. Okay, on this curve. Okay, so this is the small and this is the more. Okay, and 64 is the less for this one. We have to compare, 54 is more and 60 is less and 64 is less and 68 is less. It means when we are applying with, it means with increase the potential, the bump moves upward and it becomes maximum. For 50 volt voltage and theta equal to 50 degree. At the still higher potential, we have to applying the higher potential, the bump gradually disperses. Okay, that will be disappears. Okay, when we have to applying the more voltage apply ಮಾಡ್ಕೊಂತಾಗ ಏನಾಗ್ತದೆ, ಈ bump ಏನಾಗ್ತದೆ, that will be disappears. Okay, so that will be the curve, we are not getting the bump in this curve, smooth curve. Okay, but here we have to 50, that will be more bump. Okay, this will be more bump, that will, this angle is, what is that, 50 degree. This angle is theta is 50 degree. Okay, okay, according to the de Broglie, so we know that already, what is that, according to the de Broglie, the wavelength associated with the electron accelerated through the potential of voltage is given by, that will be given by, what is that, lambda equal to 12.27 divided by root of V. So here, what is that, we have to apply in the 54 voltage, we have to substitute in the voltage 54 and we are getting, what is that, lambda equal to 1.678 epsilon. Is that? So this is the wavelength of the electron, that is lambda equal to 1.67 epsilon. This is the wavelength of the electron beam. Okay, so this is the wavelength of the electron beam. Here, according to the Bragg's law, so here, and according to the Bragg's diffraction law, the wavelength lambda of the diffracted light is from the material of the thickness d, that will be given by d equal to that 0.91 into 10 raised to minus 10, that will be epsilon. Okay, here according to what is that Bragg's diffraction formula, that is given by what is that lambda equal to 2d, n lambda equal to 2d into sin theta. Okay, here we have to n equal to 1. Here theta is the glassing angle. What is that? Theta is the glassing angle, and it is mathematically defined as theta equal to what is that 90 degree minus t psi by 2 or theta by 2. Here theta equal to what is that 50 degree, because here we are what is that we are getting what is that this is the 50 degree. So when we are applying at 54 degree, where the angle is what is that 50 degree, therefore we have to substitute in this xi what is that 50 degree, and we are getting the theta equal to what is that 65 degree. Okay, here according to the diffraction formula, that is lambda equal to 2d sin theta, and we know the value of d, and we know the value of this theta, and finally we are getting the lambda equal to what is that 1.65 epsilon. Here what is that, finally we have observed that the wavelength of the de Broglie wavelength and Bragg's law, that is the we are getting the same value. Okay, so here what is that we have observed that the value of the wavelength from both concepts, that is the de Broglie hypothesis agirbodu and Bragg's law agirbodu, we are getting the same wavelength of this concept. Okay, so this is the Devission and Germer experiment. Okay, so thank you for giving this one opportunity, and so this is the very important for the 10 markers questions. Okay, thank you.